Okay, this is a quick review of how to add, subtract, and multiply polynomials. We want to move through these operations on polynomials fairly quickly because it's going to take some time to learn the several ways you can divide polynomials, assuming some factor or some term can be factored out of a polynomial. So this is something that's not been taught before. The division is not something that's been taught before. The other operations, addition, subtraction, multiplication, you have some experience with those. So I want to cover that quickly so we can spend next week over the division. Okay, so recall when we were adding, subtracting, and multiplying functions. We can imagine that this is a function, say f of x. This is g of x. How do we add the two? Because addition is commutative, it really doesn't matter that we have any parentheses here. So now we just have to attend to the like terms, making sure that we combine like terms. So let's do that. We have an n squared, I have a negative 3n, I have a positive 1, and a positive 2n, and a positive 3. Combining like terms, I start with the highest degree. The monomial with the highest degree is n squared. Then I have a negative 3n and a positive 2n. You add them up, I get negative 1n. I add up the constants, 1 and 3, and I get positive 4. So that is our expression. That is the sum of those two polynomials, a binomial and a trinomial, or more generally, polynomials. Okay, so there's a very, very few ways you can go wrong on addition. With subtraction, the same problem that occurred with subtraction of functions shows up in subtraction of polynomials. A lot of students forget to distribute that negative. You're subtracting both terms inside that parentheses, so you need to attend to this when it addresses both. So subtraction is not commutative, but we don't need the leading parentheses. So we have n squared, subtract 3n plus 1, subtract a positive 2n, and subtract a positive 3. Now that we have it in that form, it looks like addition. We can circle our monomials or each term, making sure that we circle the operations because those become the signs of each term. Combine the ones that are like. We have negative 3 and a negative 2, or a negative 5n, and a positive 1 and negative 3, or overall negative 2. Notice how this is very different than that. You're adding the same functions. That's your answer. You subtract one function from another, a different answer. Now, product. A monomial, a single term multiplied by any polynomial, is just going to be the distribution of that term to all three terms inside this trinomial. When you're multiplying a binomial times a binomial, remember you can use the FOIL method, or you can use an area model. When you get to a binomial multiplied by a polynomial with 3 or more terms, it's usually best to go straight to the area model. So in this way, we can look at something as a base and a height. So the area model, if you recall from geometry, the area model, the area is the base times the height. The base we can define as any of those two terms or two polynomials. I'll say that this column is n squared, this one's negative 3n, and the last one's a positive 1. My rows will be defined as 2n and a positive 3. So the area of this rectangle, which is base times height or length times width, if you recall from middle school, we use the base and height now for high school. It's just the same as the sum of the parts. So the total area is the same as the sum, the addition of all the parts. The parts in this case are the product of each of these sections. So this is 2n, this is n squared. The product of those two is 2n to the third. Product is negative 6n squared. Product is 2n. Product is 3n squared. Product is negative 9n. And product of 3. Now, it's not always the case, but you will often find that your diagonals are like terms. This makes it easy to add them up. So the product, or the sum of the parts, is 2n to the third. We combine the 3n squared and the negative 6n squared, and we have negative 3n squared. Negative 9 add 2 is a negative 7n, and 3 is our constant. There's your solution for the product of those two polynomials. Okay, now go off and practice.